The third and final day of transformations for standard number 5. The first two videos from Tuesday and Wednesday, everything you need for this standard is in there except for one thing, and that's how to find the center of a rotation. All right, so far yesterday when I taught you rotations, the center of every rotation was the origin itself. I tried to give you the clock analogy, and the center of the clock was the center of rotation. So if the hand spun to the right, that was clockwise. If the hand spun to the left, that was counterclockwise. So if you had a little triangle up here and it ended up over there, it got spun clockwise with the center of rotation at the center of the clock. Right, the object or the point that's being rotated is at the end of the hand of the clock, and the center is at the beginning of the hand in the middle. Well, the center of rotation does not always have to be at the origin. So let me start with showing you what it looks like, an easy way to find the center if it is at the origin. So here's a little triangle. I call it triangle 1. It's right here. If we spin this 90 degrees clockwise, which I'll say CW, it's going to go from quadrant 2 to quadrant 1. That's what these Q1, Q2, Q3, Q4 things mean. Quadrants 1, 2, 3, and 4. So let's spin this 90 degrees clockwise, and it's going to end up in the upper right-hand corner of our slate, which is where quadrant 1 usually is. So imagine this is quadrant 1, and this is triangle 2, or we'll just call it 1 prime. So 1 went from over here to right here in quadrant 1. All right, so let's spin it back and remember where that triangle is. It was long on the y-axis and short on the x-axis. So we spin it back, we're starting here, and when we spun it, it ended up right here. That would be 2, I'll call it triangle 2. That's where triangle 1 ends up if we spin it 90 degrees clockwise. All right, so if the center of your rotation is at the origin, you can spin your paper or spin your slate, and it'll show you where it's supposed to go. It works when it's at the origin. That spinning the slate thing, that does not work when the center is not the origin. So let's say you get a problem that looks like this and says, this is where you started, this is where you ended up. Which way did you rotate? Well, you rotated clockwise because you rotated this way. If you would have rotated counterclockwise, you would have ended up down in quadrant 3. You would have ended up in the bottom left-hand corner down here. So if you rotate 90 degrees counterclockwise, then your triangle would end up being right here. We'll call that triangle 2. That would be 90 degrees counterclockwise, put you down here. So you got to be able to tell first and foremost which way you're rotating, clockwise or counterclockwise. And that was explained yesterday, and it was in the do problems from Tuesday. So you got practice at that already. So I hope you know how to tell if you're spinning clockwise or counterclockwise. What is a little bit trickier is figuring out what the center is if it's not the origin. So for example, let's say our triangle is right here to start. Triangle 1 is right there. Now, if triangle 2 is the result of a 90 degrees clockwise spin, then it's going to be down here somewhere in quadrant 4, right? Because clockwise is from 12 to 3. So if we spin it clockwise 90 degrees, we're going to end in the bottom right-hand corner, which is our quadrant 4. So if we spin 90 degrees, it's going to look something like this. Right? Now imagine that that's not where it ends up. Let's say it ends up right here. Say our quadrant or triangle ends up right there in quadrant 4. That's still spinning it 90 degrees clockwise, but if we spin our slate, you can see in quadrant 4, our triangle is moved away from the y-axis. But really, this picture shows it right on the y-axis. That means the center is not the origin. The center is some other point, not the origin, because when you spin your slate, these two don't match up. So how are you supposed to figure out where that is? Good question. What you have to do is find a corresponding point in each triangle that are either straight up and down from each other or straight across from each other. It's the easiest way to do it. So a corresponding point. Here's a point way out at the tip of one. Here's the point that corresponds to it. Those are diagonal from each other, so don't use those points. Here's one at the top of the short end. Triangle 2, that's the top of the short end. Those are diagonal from each other. That doesn't work. Here's one down in the right angle corner. That's this one. Those are straight up and down from each other. Those work. So we're going to focus on those two corresponding points because they're straight up and down from each other. And we're going to see how many spaces are in between those points. Well, I'll put little grids on here. We'll say that that's 1 and this is 2. So there's 2 spaces in between those points. We got to split that in half. What's half of 2? It's 1. What is in between 1 and 2? Or 0 and 2? What's in between these 2 points? This right here. How did we get to there from either one of these? We went 1 space. So now we have to go 1 space either to the left or the right, and that's going to be our center. So imagine if we went 1 space to the right and said this is our center of our clock. How would you spin from trying from that point to here? Would you spin, you would have to say, here's my hand on my clock, it's at the center, and I spun to get there this way. That's a 90-degree spin, but that's counterclockwise. We didn't spin counterclockwise, we spun clockwise. So we have to go over 1 space this way, and that's our new center. If this is the center of our clock and we're pointing at our original point and we spin 90 degrees clockwise, we're going to end up right there. So that's the key on how to find the center. You split the distance between your 2 points, and then you go that distance left or right. So let me say that again. You split the distance between your points that are straight up and down from each other or straight across from each other. That's these 2 points. So you split that distance. The distance between these 2 points is 2. Splitting that distance in half is 1. So this is exactly in between those 2 points, and it's 1 space away. So now we have to go 1 space, the same distance to the left or the right. Let's say 1, 2, 3, 4. Let's say there's 4 spaces in between those points. What's the middle? 2. So we'd have to go 2 spaces to the left. Whatever we have to go to get to the middle, we have to go that far to the left. If we're going clockwise, we have to go that far to the right if we're going counterclockwise. So you're going to have to use your imagination a little bit on this one with the spinning of the clock hand. All right, if you're spinning clockwise, the center of your clock needs to be to the left of your points to get from here down to there. If you're spinning counterclockwise, the center needs to be to the right to spin down. All right? So that's where the imagination comes in. Am I going 2 spaces to the left or 2 spaces to the right? But to figure out where that is, it's splitting the difference. If there's 6 spaces in between here, 1, 2, 3, 4, 5, 6, then you would say half of 6 is 3, and you would go left 3 spaces. So your center would be at -3, 0. All right, so that's how you find the center when it's not the origin. So here's your work for today. I can't find any problems in the book that are like this, so I had to make up my own. So here are your 4 do problems for today. Let's see if I can get those all on the screen at the same time. All right, this says find center down here. So there's 4 problems where you have to find the center of the rotation. So for example, problem number 1 is up here in the upper left-hand corner. You're going to start at triangle 1 and rotate to triangle 2. So you got to tell me 2 things. Did you rotate clockwise or counterclockwise? And then where was the center of your clock? Where's the center of your rotation? It's not going to be at the origin, because if it was at the origin, triangle 2 would not be right there. It would be over here floating in quadrant 1. Triangle 2 is not floating in quadrant 1, it's stuck to the y-axis. So none of these are going to be at the origin. So there's one hint for you. The centers are not at the origin in these problems. They're somewhere else, and you got to split the difference between points, corresponding points that are either straight up and down from each other or straight across from each other. Split the distance, so if they're 6 spaces apart, you go 3 spaces to the left or the right from the middle, just like I showed you in the video. I know they're a little bit tricky. This is a lot easier if you guys are in the class and you're working it out on your slate and I can point you in the right direction. So I hope this works. I'm a little nervous. This is probably the most nervous I've been on one of my videos and explanations. So be prepared to ask questions while you're watching it or while you're trying to do these problems, because this is your last chance. We're not going to meet before class tomorrow. You're just going straight to the test.